Welcome to Earth, Analyst, the little space where curiosity finds a gentle pace and the big questions of our planet arrive without any rush at all. Tonight's thought is a quiet one, but also the kind that can slowly settle into your mind and linger long after you first heard it. It's not about what people are doing now or what news fills the headlines. It's about something much wider, something that belongs to the Earth itself. It's about what the world looks like when no one is here to see it. When the landscapes and oceans and skies exist without a single human voice to name them. That might sound like the beginning of a science fiction story, the kind that imagines futures without people or distant worlds untouched by us. But what I mean is closer than that, and older too. Think of the vast history of Earth, billions of years stretching back so far that our entire human story, every city ever built, every life ever lived, fits into only the tiniest fraction of the timeline. The rest belongs to mountains and forests, seas and deserts, glaciers and rivers, life that rose and fell long before the first person walked across the ground. If we imagine Earth without us, we aren't looking into fantasy at all. We are looking at nearly all of Earth's past. Before we go any further, I'd like to know where you're listening from. Is it night where you are, with the darkness already wrapped gently around your room? Or is there sunlight spilling across your window right now? Maybe you're traveling, the world moving quietly past you. Or maybe you're resting still in the chair that feels most like yours. Wherever you are, you and I are sharing this moment to lean into an idea that asks us to picture a world without people, not gone, not empty, but alive in a way we rarely imagine. And if this kind of journey feels like the company you've been looking for, calm, steady, curious, without hurry, I'd be grateful if you gave it a like, or subscribed, or even passed it along to someone else who might need a few gentle thoughts tonight. It's a small thing, but it helps these quiet reflections find new listeners. In its own way, it's a little like keeping a lamp burning for fellow travelers. So let's begin by thinking about the Earth itself, not the Earth as we know it today, with its roads and towers and voices, but the Earth as it was before any human ever left a footprint. There were no bridges, no farms, no borders marked on a map. There were skies full of storms and sunrises. There were oceans that stretched without names. There were mountains that lifted and eroded in rhythms far beyond human lifetimes. Continents drifted slowly, colliding and breaking apart across millions of years, shaping coastlines that would one day look nothing like the ones we know now. It's easy to think of this pre-human Earth as silent, but it wasn't silent at all. It was alive in every corner, forests thick with creatures, seas filled with motion, skies crossed by wings. Some animals grew massive, others small and fleeting. Some of them carried instincts and intelligence we would recognize even now. The Earth without humans was not an empty wilderness. It was a place of endless voices, just none of them ours. We tend to imagine human thought as something unique, as if only we shape the world with our minds. But intelligence and adaptation have always belonged to Earth in many forms. The play of dolphins, the cleverness of birds, the patient strategies of predators and prey, all of it unfolded long before we arrived, and all of it still belongs to the Earth, with or without us. Dolphins recognize themselves in mirrors. Octopuses use tools that's in the world as it is now, with people in it. But what happens when the story has no people at all? What if intelligence doesn't leave behind cities or technology, but simply moves quietly through forests, oceans, and skies? A world without us is not a world without thought. It is simply a world where thought belongs entirely to the animals, the winds, and the shifting rhythms of nature. The earth itself is a patient host. It remembers some things for ages, yet it erases others almost as soon as they appear. Look at a modern city. If it were left empty, plants would begin to crack the pavement within a few years. In a few decades, buildings would weaken, roots and water working their way through concrete and steel. Give it a few centuries, and forests would rise where streets once ran. Rivers might shift their paths. Roofs would collapse under vines and moss. In 1,000 years, little would remain that spoke of people at all. Stretch the timeline further, thousands, then millions of years, and even the most stubborn materials would vanish. Seas would rise and fall. Glaciers would come and go. Volcanoes would pour out new stones. Continents would drift and collide, burying layers of the past beneath mountains or deep oceans. The earth is always rewriting itself, layering new chapters over the old. If you were to walk across those landscapes, there would be no sense that people had ever been there, only the steady presence of forests, deserts, oceans, and skies. It's not that the earth tries to erase us. It's simply the way of the planet. Constant change, constant renewal. Stone crumbles, rivers carve, wind carries, oceans reshape. What looks permanent to us, glass towers, metal bridges, vast cities, is only temporary in the language of geological time. A world without humans is not an abandoned world. It is a world that simply keeps moving, keeps breathing, keeps living in its own timeless rhythm. They've been carried miles from where they first formed. The older the layer, the less it remembers. This is part of why scientists sometimes describe the Earth as both an archive and an eraser. Every grain of sand, every layer of rock carries the memory of a moment in time, but it also buries the memory of what came before. If humans were to disappear, the same forces would quietly take hold. Our roads, our towers, our machines would not vanish overnight, but over centuries and millennia, the planet would fold them into its geology, the way it has done with forests, seas, and mountains for billions of years. If you looked for us in the far future, there might still be traces, a thin layer of unusual metals, fragments of plastics turned to stone, a faint chemical signature frozen into sediments or ice. These things could linger for millions of years, long after the last building had crumbled. But they would be subtle, easy to overlook, unless you knew exactly what you were seeking. To most eyes, the planet would simply look whole again, wild, unbroken, alive in its own rhythm. And perhaps that is the humbling thought. A world without humans would not feel abandoned, only restored to its deeper patterns. We often imagine our mark as permanent, but in the vast span of geological time, it is fleeting. Mountains rise and fall, rivers shift, continents drift. Our age would be just one thin page in a library of stone, easy to miss, quickly replaced by whatever comes next. To think about this is not to imagine secrets or conspiracies, but simply to recognize our small place in a story that began long before us and will continue long after. We like to think of ourselves as the center of the story, the final chapter, the pinnacle of life on Earth. But in truth, we are only one small part of a much bigger tale, a tale still being written, and one that has already turned countless pages before us. Mass extinctions have reshaped life again and again. Ecosystems have risen, flourished, and collapsed in what, geologically speaking, was the blink of an eye. And intelligence, even in the forms we recognize today, has always been scattered, never a straight ladder with us at the top, but a tangled, branching web of possibilities. To imagine the Earth without humans is not to picture emptiness, but to understand the richness of a world that thrived long before our arrival, where life followed its own rhythms, free from our hands and our gaze, before calendars, before clocks, before even the thought of measuring time. The Earth was already old. By the time the first humans appeared, the planet had lived through billions of sunrises and sunsets, long enough to wear entire mountain ranges down to dust, long enough to lift new peaks out of the seabed. The continents we see on maps today were not fixed in place. They wandered slowly, colliding, breaking apart, drifting across the globe like great stony rafts floating on a restless sea of molten rock. If you had looked at the Earth from space tens of millions of years ago, the view would have been familiar, yet strange. There would still have been blue oceans, green land masses, and the white swirls of clouds. But the shapes would not match any map, you know. Oceans gathered in unfamiliar patterns, and continents leaned close or drifted apart in slow, silent journeys. The climate, too, was ever-changing. At times the planet was warm and wet, its forests stretching almost to the poles. At other times, ice crept down from the north and south, covering vast lands in frozen silence. Seas rose and fell, drowning coastlines, then pulling back to reveal them again. The Earth never stood still, and it never will. In those vast ages, without people, life filled almost every corner of the planet. The ocean floors teemed with creatures that never saw the light of day. Coral reefs grew, collapsed, and grew again in new places, each time a riot of color and motion. Swamps rang with the calls of strange animals we can only picture with the help of fossils. On land, forests stretched wide with trees whose closest relatives are long extinct, and beneath their canopies moved creatures of every size, from delicate insects to towering giants, each finding its place in a world that was complete without us. Insects were among the oldest of Earth's survivors, already thriving long before the first dinosaurs walked the land. Birds slowly emerged from small feathered reptiles, learning to ride the winds that shifted above primeval forests. Mammals were present too, though for much of that time they were small and cautious, living in the shadows of much larger neighbors. If you could step into one of those ancient landscapes, it might feel both familiar and unsettling. A tree would still look like a tree, and rivers would still tumble downhill. The air would still move in breezes and gather into storms. The sun would still climb each morning and sink at night. And yet, the details would tell you that this was not your world. The sounds would strike your ears as strange, unlike any chorus. You know, the plants, though green and reaching for the light, might carry leaf patterns shaped for climates that no longer exist, textures and colors suited to a world that has passed away. The animals would be a blend of the recognizable and the utterly alien. Some were ancestors of species alive today, carrying hints of the familiar in their shapes. Others left no descendants at all, vanishing completely, their legacy preserved only in stone. Life here was not silent or simple. Creatures gathered in herds, flocks, and colonies. They communicated in ways we can only guess at, through sounds, through colors, through movements that once carried meaning but are now lost to time. They hunted, they migrated, they raised their young. Some had minds capable of remarkable behaviors, though not in ways we would easily call human, and yet it was enough. Without us, the Earth was still alive with purpose, rhythm, and adaptation. It was a planet constantly experimenting, filling every niche, trying every possibility. Long before our kind appeared to wonder at it, we know that great changes are possible because they happened long before we arrived. The Earth itself followed a path from simple beginnings to extraordinary variety, not through sudden leaps, but through patient steps across hundreds of millions of years. Life did not appear overnight. It was shaped by shifting climates, drifting continents, and the constant pressures of survival and adaptation. We can imagine that if you could step into these earlier ages, you would find different creatures rising to prominence, each molded by the opportunities and challenges of its time. Not in our human era, but in the countless other worlds that flourished before us. The trouble is that the record of these times is incomplete. Fossils are rare, forming only under just the right conditions. Most living things vanish without leaving a single trace. They return to the soil, are consumed by others, or decay beyond recognition. Even when bones are preserved, they tell us only fragments of a story. A skeleton can reveal size, shape, and diet, but not the colors of feathers or scales, not the sounds an animal made, not the intricate ways it may have behaved. Entire worlds of behavior are lost, leaving us only hints. The Earth's surface itself does not keep still. Mountains rise and wear away. Rivers carve valleys, then change course. Oceans spread and retreat, swallowing land and revealing it again. Much of the crust is recycled over deep time, carried down into the planet and reborn as new rock. Any single moment in Earth's past must survive all this motion if it is to be remembered. And yet enough has endured for us to glimpse those vanished worlds. Enough to remind us that our planet was thriving and full of life, long before humans ever took their first steps, and the odds of anything lasting that long are very small. Even when life leaves behind traces, we must be able to recognize them for what they are. A shell pressed into stone might go unnoticed unless it is revealed at the right angle. A layer of unusual minerals in the rock might be passed over unless someone stops to ask what ancient forces created it. When you think about the scale of time involved, it becomes easier to see how entire worlds could disappear almost entirely. Imagine a continent covered in forests, rich with animals and plants, reshaped again and again by ice, by rising seas, by shifting mountains. Over millions of years, the landscape would be erased and written over until only fragments remained now. And then, the Earth keeps a memory longer than usual. There are fossilized forests where the trees still stand, turned to stone. There are insects sealed in amber, their wings and colors preserved for tens of millions of years. There are footprints pressed into mud that hardened and became rock, holding the shape of a moment that would otherwise have been lost. These are accidents of preservation, rare coincidences of geology and time. For an entire ecosystem, an entire world of life, to survive in such detail would take an extraordinary combination of luck and conditions. Without it, the past fades quietly into silence. Yet enough remains for us to know that Earth's history is vast, layered, and fragile, each discovery like a window into an age when our species was not yet here, and the planet belonged entirely to other forms of life. And once you begin to picture it, it's hard not to wonder what those earlier worlds must have looked like. Were they covered in dense forests that stretched without end, or open plains where herds of strange animals moved with the seasons? Did rivers cut deep valleys only to be redirected by shifting land? Did colors and shapes of life bloom in ways we would barely recognize today? Would the patterns of their songs, their displays, their movements feel familiar to us? Or would they be as foreign as another language? We don't have all the answers, but we do have the ability to imagine. And imagination is sometimes the first step toward discovery. Scientists ask questions, not only from what is found, but also from what might once have existed, guiding their search through curiosity. The Earth has been many different worlds over its lifetime. Each age carried its own climate, its own landscapes, its own cast of living things. The version we know today, with its continents, oceans, and polar ice, is just one in a vast series. Long before we arrived, there were jungles where deserts now lie. There were ice sheets where open seas now roll. There were creatures with shapes that defy our sense of the familiar, and plants that would look out of place in any modern forest. All that change, life continued to rise, flourish, and vanish, leaving behind traces we now study with care. Long before humans appeared, the Earth was never silent. It rang with voices that belonged to other species, with rhythms and calls that filled the air, the seas, and the forests. The planet was alive with sound, just not the kind we would recognize as our own. The rush of wind once moved through plants that no longer exist. The deep calls of animals echoed across valleys, their voices now silenced except for the bones they left behind. Water carved its way through ancient landscapes, grinding, trickling, reshaping the land into forms we would not even recognize today. And somewhere within all that, there may have been minds at work, minds that noticed patterns, remembered not only for survival, but simply because they could. Minds that dreamed. Dreaming is not ours alone. We know this from the way animals behave in sleep, the twitch of a dog's paws as if running, the hidden movement of a bird's eyes beneath its lids. Dreaming seems to arise naturally wherever brains are complex enough to weave memory into imagination. It does not need words. It does not need books or cities. It simply needs a nervous system that can turn experience into visions of something more. In that sense, countless species before us may have dreamed. Some dreamed of hunting, of hiding, of shelter, but perhaps a few dreamed beyond their immediate needs. Perhaps they imagined new possibilities, tools, new ways to live, new ways to shape the world around them. A mind that can imagine change holds the seed of invention, the The step from using a found object to shaping one for a purpose is small in time, yet enormous in consequence. It means no longer being entirely at the mercy of the world, but beginning to reshape it. It means building, preparing, passing down knowledge. We see glimmers of this today. Chimpanzees' teaching tool use birds bending wires to reach food, dolphins inventing hunting strategies and sharing them with their young. These are sparks of culture, showing us that intelligence is not all or nothing, but a wide spectrum. If we look back across deep time, it is not difficult to picture some branch of life reaching further, their cooperation and creativity growing with each generation. Given millions of years, even the smallest beginnings could grow into something extraordinary. But what would it truly take for that leap from cleverness to civilization to happen? Large brains can help, but they are not the whole story. Intelligence is not just a matter of size. It grows in places where minds need to understand one another, where predicting the behavior of others can mean the difference between survival and failure. It grows in places where communication carries ideas beyond a single lifetime, where a discovery is not lost when one creature dies. It grows in the soil of curiosity, the restless drive to explore, to test, to imagine something more than what is immediately necessary in our own lineage. All of these things aligned. But perhaps they aligned before, under skies we will never see, among creatures we will never know. We tend to imagine intelligence in our own shape, upright bodies, forward-facing eyes, hands nimble enough to carve stone or write words, voices capable of layered sounds. Yet these are only the tools of our body plan. Another lineage might have followed a different path. Perhaps intelligence once grew in the water, with tentacles or fins used to shape and explore. Perhaps it took to the air with sharp eyes scanning landscapes from above, weaving knowledge into maps of the world below. Perhaps it was small, thriving through sheer numbers and cooperation instead of strength. Intelligence is adaptable. It makes use of whatever form it inhabits. If such a species existed, its dreams would have been just as varied as our own. Perhaps they imagined safer shelters, better strategies for feeding, or gentler ways of raising their young. Perhaps they told one another stories, though not in words we would understand. Perhaps they decorated their homes or created patterns of sound and movement simply because they took pleasure in them. Art is one of the most mysterious markers of intelligence because it is not required for survival. And yet, when it appears, it whispers of minds reaching beyond the present moment, of creatures that found beauty in their world and wanted to leave a trace of that beauty behind. It suggests a kind of mind that valued beauty or symbolism, or simply the act of creation for its own sake. And that is the kind of mind that might leave traces worth finding. Yet most dreams do not leave a mark we can touch. Even in our own history, the vast majority of what we think and imagine disappears the moment it is dreamed. Civilizations leave behind only a fraction of what they build, and time is a patient eraser. The further back we look, the more fragile the evidence becomes. If the first minds that dreamed also built, their creations would have needed to survive the slow erosion of the ages. Stone can last longer than wood. Fired clay endures longer than fibers or cloth. Metals may survive but they can also dissolve back into dust, given enough time. Without special conditions, almost everything made by hands or fins or claws will eventually vanish. Even our own cities, built with steel, glass, and concrete, begin to decay almost immediately. Without care, roads split and crumble. Buildings collapse and sink into the ground. A few centuries without repair, and their outlines might be little more than faint scars visible from the air. A few thousand years, and even those scars might vanish beneath soil and forest. 1,000,000 years, and the difference could be reduced to subtle shifts in the Earth's chemistry. Tens of millions, and almost nothing would remain at all. This is why, when scientists speak about the possibility of an earlier civilization, they do not expect to find monuments still standing or tools lying neatly in place. Instead, they look for indirect signs, fingerprints left in stone and atmosphere, unusual patterns in sediment, sudden shifts in climate that cannot be explained by natural cycles, layers of material that do not belong, that could hint at fire or industry, or something that once changed the planet in ways far beyond chance. These traces would be less fragile than buildings or tools, more like the geological equivalent of footprints pressed into a path long ago. Yet even those are rare, and the Earth itself is a master of producing strange patterns. Separating what was made by hands or by intention from what was shaped by wind, fire, or pressure is one of the hardest challenges when we look back tens of millions of years. Still, the thought lingers. At some moment in the planet's deep history, it is not beyond possibility that the first minds capable of dreaming as we do began to take the first steps toward something greater. Perhaps they lived in small bands, at first scattered across landscapes filled with predators and shifting weather. Perhaps they learned to find safety in caves, or to weave shelters, or to build platforms that could last beyond a single season. Maybe they discovered how to harness fire or some other form of controlled energy that reshaped their nights and their survival. With each step, their world would have grown more different from that of the creatures around them. And if they reached the point where they could shape their environment on a larger scale, they might have spread outward into new territories, learning to adapt to new climates and new resources. Trade may have emerged, first as simple exchanges of food or rare materials, and then as something more structured. Over time, their knowledge might have accumulated until centers of life began to form, something like our earliest cities, places where ideas, goods, and skills came together. We cannot know the details, but the shape of the path is familiar. It is the same path we eventually walked, and it is one that evolution could have traced more than once across the ages. Whether any trace of those earlier journeys remains for us to discover is another matter entirely. The record of life on Earth is broken and incomplete, even for species we know once thrived. Whole chapters are missing, leaving only scattered fragments to hint at what was lost. That is why the question is so difficult to settle. The absence of evidence is not proof that something never was. It is simply a reflection of the way this planet moves, forever shifting, erasing, and rewriting its own history. All we can do is imagine the first minds that dreamed. We can place them in landscapes now erased, try to hear voices in patterns of sound we no longer understand. Perhaps they were nothing like us, or perhaps they shared more than we expect. The possibility alone is enough to remind us that our place in the story of Earth may not be as unique as we like to believe. Intelligence may be rare, but it may not have been singular. The Earth may have nurtured it before, and it may do so again. From here, the question deepens. It is not just whether it could have happened, but what we even mean when we speak of civilization. The word tends to conjure images of tall stone buildings, wide roads stretching across valleys, art carved into walls, laws written down, governments formed, and people gathering in numbers far greater than any single family or tribe. But is that the only form civilization can take, or simply the one we know best? But those are only the familiar examples from our own story. If we strip the word down to its essence, civilization is not about stone towers or a particular form of government. At its heart, it is a way of living where knowledge, culture, and technology accumulate across generations, and that accumulation transforms how a society exists. By that measure, civilization doesn't have to look a certain way from the outside. A people could build their shelters from leaves, wood, or clay, leaving no ruins for us to find, and still live within a framework of shared systems, organized knowledge, and deliberate ways of shaping their world. Permanence is not the measure. Complexity is. We also tend to think of civilizations as vast empires, nations, great cities, but human history reminds us they began small, scattered communities, linked by exchange and shared practices, long before kings or capitals existed. What connected them was not size or grandeur, but the web of ideas and traditions passed from one generation to the next. That cultural memory, that continuity, was what made them part of something larger. If a pre-human civilization ever existed, we would have to imagine it with the same flexibility. It may not have looked like Rome or Mesopotamia. It may not have grown out of farming at all. It might have relied on resources alien to us, perfectly suited to the species that created it. Even the idea of a city may have been foreign to them. Perhaps instead of permanent clusters of stone, they gathered seasonally in places marked only by paths and shared landmarks. Civilization does not always need walls. One of the hardest parts of defining it is that we instinctively measure by our own standards. We prize writing, but oral traditions can preserve knowledge for centuries with astonishing accuracy. We revere monumental architecture, but a society might create its most advanced achievements in fragile materials, woven fiber, carved wood, or even living arrangements of plants, things the earth would never preserve. We often admire the great engineering feats of the past, but small and precise interventions in an environment can be just as revealing. If a non-human civilization did exist millions of years ago, its way of life might not fit neatly into our categories. They may never have planted crops in rows or herded animals in pastures. They may never have fired pottery or forged tools from metal. Instead, they could have relied on organic materials, woven, carved, or shaped in ways that left no trace once they decayed. If that were the case, the record of their existence would not lie in broken monuments, but in more subtle signs, patterns. In the landscape, rivers shifted from their natural courses, soils altered in unusual ways, or the sudden spread of plant species far from where they first evolved. This is where the definition of civilization becomes so important. If we restrict it to the forms we already know, cities of stone, written language, agriculture, we risk overlooking other possibilities. If we expand it to mean any sustained, organized way of life that shapes its environment and preserves knowledge, then a wider range of evidence enters the conversation. That doesn't mean every animal society qualifies. Ants and bees build vast colonies and intricate structures, but their behavior is driven almost entirely by instinct, not by cultural evolution. The difference lies in innovation that builds on itself, in changes carried not by genes alone, but by ideas, learned and shared across generations. When archaeologists study our own past, they don't only look for buildings or metals. They look for signs of long-distance exchange, of specialized roles within a community, of symbolic expression, and of groups large enough to extend beyond immediate families. None of these require stone walls or bronze tools. What they require is cooperation, organization, and the weaving of culture into a fabric strong enough to last beyond the lives of individuals. These are the kinds of markers that could, in theory, appear in the fossil record of a non-human species, though finding them without direct artifacts would be extraordinarily difficult. There is also the question of time. How long must a civilization endure before we consider it significant? Some human cultures have lasted thousands of years, while others rose and vanished in only a few centuries. Yet, even in that brief span, the impact was immense. Forests were cleared, rivers redirected, species carried from one continent to another. Those changes sometimes survive in sediments, tiny signals of human presence that remain long after the buildings and tools have disappeared. If a pre-human civilization lasted long enough to reshape ecosystems on a large scale, we might expect to see echoes of that, even if we did not at first recognize them. But here lies the challenge. Nature itself often creates patterns that seem artificial. A round hill might be nothing more than the weathered shell of an ancient volcano, not the foundation of a forgotten city. Straight lines in stone can emerge from natural fractures rather than deliberate construction. Even sweeping shifts in vegetation may reflect changes in climate rather than intentional cultivation. This is why identifying a true civilization would require more than one clue. We would need multiple strands of evidence-altered landscapes, unusual chemical signatures, perhaps even fossilized remains of the species itself, showing traces of behavior beyond simple survival. And that brings us to an even deeper question. What would such a species have looked like? We often assume that intelligence requires a body like ours, with hands or tentacles capable of delicate manipulation. But intelligence does not belong to a single form. It could emerge in creatures very different from us, shaped by environments we can only begin to imagine. That assumption that intelligence must look like ours exists because most of our technology depends on hands and fine tools. But if a civilization evolved with different capabilities, its path could have been very different. Instead of crafting delicate objects, it might have focused on shaping entire environments. Such beings could have been aquatic, leaving behind few traces we would recognize in the fossil record. They might have been flighted, nesting high in cliffs or trees, building with materials that decayed quickly. Their architecture could even have been alive, woven from plants or coral-like organisms that grew and shifted with time. Thinking in these terms forces us to step outside the narrow comfort of our own history. It reminds us that our way of life is just one possibility, not the template for all intelligent species, even today. Glimpses of these alternative paths exist in the world around us. Elephants reshape their landscapes by knocking down trees and digging water holes, altering ecosystems in ways that last long after they move on. Certain birds build intricate structures for courtship, sometimes expanding or reusing them across generations. Whales sing across oceans, passing information from one group to another through patterns that evolve over seasons. None of these behaviors quite cross the threshold into what we call civilization, but they hover near it, suggesting that, under different conditions or given more time, they might have gone further. Once we open ourselves to the idea that civilization does not always need to resemble ours, the next question is how we would ever find it in the deep past. The search would not begin with obvious ruins, but with subtler traces, chemical anomalies in rock layers, unusual patterns in sediments, sudden appearances of species outside their native ranges. It would require collaboration across many sciences, patient comparisons of data, and the willingness to ask whether an odd finding might represent deliberate action instead of chance. The challenge is vast, but so is Earth's history. For billions of years, this planet has been an experiment in life. We know of one civilization for certain, our own. It is not unreasonable to wonder whether there might once have been another. Whether any traces remain depends as much on how we define them as on whether we are prepared to see them in unfamiliar forms. This brings us to the question of what signs we could actually detect if such a thing had ever happened. When people imagine uncovering the deep past, they often picture paleontologists brushing away the last grains of soil from a perfectly preserved skeleton, as if the creature had only just lain down to rest. The truth is far less dramatic, far more fragile. Most of the past has vanished. What survives is a scattering of clues, broken, altered, and compressed until they resemble shadows of what they once were. Scientists who study them work more like translators than treasure hunters, piecing together a story written by the Earth itself in a language shaped by pressure, heat, and time. A fossil is not the past frozen in place, but a transformation. Bone, shell, or leaf is replaced molecule by molecule with minerals that seep in, hardening into stone. Sometimes only the impression is preserved, a cast of the outer surface, the faint outline of a footprint, or the ripple of water caught in mud that turned solid before it could be disturbed. Just as often, those delicate traces never form at all. They are washed away, crushed, or buried so deep that they will never return to the surface. This is why the fossil record is incomplete. Entire species may have lived and vanished without leaving behind a single preserved example for us to discover. The conditions that allow preservation are rare. They favor specific environments, river deltas, where silt buries remains quickly, calm lake beds, where sediment builds in layers, seafloors, where fine particles rain down, or volcanic landscapes, where ash entombs everything in an instant. In contrast, dry uplands, forests, and shifting coastlines erase more than they protect. The result is a record full of gaps, skewed toward certain places and certain moments. For anyone searching for evidence of a civilization that came before us, that bias is an enormous challenge. Even in our own short span of history, the footprint of humanity is uneven, concentrated in some regions, while fading almost entirely in others. Cities built in deserts or floodplains can leave traces that endure, while coastal settlements may be erased by rising seas or buried under layers of sediment. Stretch that reality over millions of years, and it becomes clear how much could vanish entirely. If an advanced society once thrived in a region that later sank beneath the ocean, its remains might now rest under miles of water and mud. If it lived in a forested land later scoured by glaciers, the surface could have been wiped so clean that even the shape of the land itself is unrecognizable. The scientists who sift through the Earth's layers know this well. They understand that every discovery is just a fragment of a much larger, mostly invisible story. Often, the most important clues are not complete skeletons or grand ruins, but small details. A single tooth can reveal the diet, age, and lineage of a creature. A thin band of pollen caught in sediment can preserve the memory of ancient forests and climates. Chemical traces locked in stone can whisper of volcanic eruptions, asteroid strikes, or sudden and unexplained shifts in the atmosphere. It is those unexplained shifts that draw particular attention. Our own industrial age has already left chemical fingerprints that will persist far into the future. The carbon isotopes released by burning fossil fuels form a distinct signal in the atmosphere and soil. Plastics, synthetic compounds, and refined metals are now woven into sediments across the globe. Even if every building were to crumble tomorrow, those subtle yet durable markers would remain, written into the geological record for millions of years. The difficulty, however, lies in distinguishing between what is natural and what is deliberate. Massive volcanic eruptions can mimic the chemical signatures of industry. Sudden die-offs can deposit strange concentrations of elements. Nature, too, leaves puzzles in stone, and separating them from signs of civilization is a challenge that requires extraordinary care. Shifts in ocean currents can redistribute sediments in unusual ways. The fossil whisperers, as you might call them, have to weigh every possibility before considering the most extraordinary explanations. In science, extraordinary explanations require extraordinary evidence. Still, there are moments when the evidence resists the simplest answers. In certain rock layers, scientists have found sudden changes in mineral composition that suggest a rapid introduction of unusual materials, ones that don't seem to fit the slow processes of erosion and deposition. Most of these turn out to have natural explanations, but each time the question lingers, what if? What if long before us there was another hand at work, shaping the environment in ways we don't yet recognize? Finding something like that wouldn't necessarily be as obvious as unearthing a carved statue or a worked piece of metal. It might be subtler patterns in the distribution of minerals that hint at large-scale extraction deposits of rare compounds, that suggest deliberate manufacturing, or a thin layer of material whose origin can't be explained by known natural processes. Interpreting such patterns would require not only geology, but chemistry, archaeology, and even an openness to asking questions that sound improbable. There's a patience to this kind of work. Decoding the past isn't a matter of pulling one artifact from the ground and declaring the mystery solved. It's about assembling a body of evidence, piece by piece, until a picture starts to form. And in the case of a possible pre-human civilization, the picture might never be complete. It could be nothing more than hints that refuse to fade, inviting speculation without ever confirming it. That uncertainty is part of the fascination. We live in a time when it's easy to think of the past as something we can map and measure, but in truth, our knowledge is thin. The fossil record is not a complete history. It's a set of surviving fragments scattered across the globe, written in a language we're still learning to read. What it tells us is that life has taken forms stranger and more diverse than we might have guessed. That entire branches of the evolutionary tree have grown and withered without leaving much trace. And that the world we know is just the latest version of a planet that has reinvented itself countless times. In that light, the idea of another civilization lost so completely that it survives only in faint geological whispers doesn't seem entirely impossible. If it existed in a time and place where fossilization was rare, if it relied on materials that decay quickly, if its population was small enough to avoid leaving massive global changes, its traces could be as elusive as the memory of a seasonal long past. The scientists who study deep time know this, and it shapes how they look at the ground beneath their feet. Every layer of rock, every coarse sample pulled from the seafloor, every strait in a cliff face is a chapter in the Earth's story. But the pages are worn, torn, and often missing entirely. To read them well requires not only technical skill, but imagination, the ability to see how a faint trace might connect to a larger pattern. And sometimes, just sometimes, it requires the willingness to consider the most unlikely possibility. That willingness doesn't mean jumping to conclusions. It means leaving a little space for the unknown, for the chance that the Earth's long memory might still hold surprises we haven't yet learned how to recognize. From here, the question becomes how the planet itself might preserve or erase those surprises, and what forces could quietly remove nearly all evidence of something that once was. The Earth remembers, but not the way we do. Our memories are collections of moments, snapshots we can revisit, sometimes vivid, sometimes blurred. The planet's memory is slower, heavier, written in stone and ice and sediment. It keeps records in layers, each one built from the debris of what came before. But it's also a forgetful memory, constantly rewriting itself, sanding down old impressions, burying some completely under the weight of new ones. It has no sense of nostalgia, no attachment to preserving a scene for the sake of sentiment. It changes because that's what it has always done. If we could peel the crust of the Earth back like the pages of a book, we'd see a story with long chapters missing. Whole periods of time are gone, erased not because they were unimportant, but because the processes that shape the planet are relentless. Mountains rise when tectonic plates collide, then crumble under wind and rain. Oceans spread when plates drift apart, then shrink again as land closes in. Volcanoes pour out layers of new rock, covering whatever was there before. Ice sheets grind across continents, stripping away the surface like sandpaper. Even the quiet work of rivers, carrying silt from one place to another, can bury old landscapes and create new ones. The surface we see today is not the same one that existed 1 million years ago, or 10 million, or 100 million. Every place has been reshaped over and over. In some regions, the rocks at the surface today might have formed only a few thousand years ago. In others, they might be hundreds of millions of years old, but have been altered so much that any trace of what they once recorded is nearly gone. This constant recycling of the crust means that the older something is, the less likely it is to survive in a form we can recognize. For the traces of any civilization to last beyond a few tens of millions of years, they would need extraordinary luck. They would have to be preserved in a stable geological setting, one that was not submerged, crushed, or scraped away. Even then, the evidence might be distorted. Heat and pressure can change the structure of rock, melting or warping anything embedded in it. Organic materials decay quickly unless sealed away from air and moisture, and even then, time works against them. This is why so much of Earth's early history is known only in outline. The first billion years of the planet's existence are represented by only a few surviving fragments of rock scattered in places like Greenland and Western Australia. These are the barest hints of what was happening then. The rest is gone, recycled into the mantle and brought back as new rock without the original markings. The same principle applies to more recent times, just on a smaller scale. It's not only geology that erases the past. Climate and biology can be just as thorough. A jungle can reclaim a city in a matter of decades, hiding it under layers of soil, vines, and trees. Insects and microbes dismantle wood, leather, and cloth. Saltwater corrodes metal. Even stone can be eaten away by plants, rain, and frost. On a human timescale, ruins may seem permanent, but compared to the lifespan of the planet, they are brief interruptions. If we vanished tomorrow, the most visible signs of our presence, roads, buildings, bridges, would be fading within a century. In 10,000 years, most would be gone or unrecognizable. In 1 million years, only scattered traces might remain, buried deep in sediments or transformed into minerals. After 10 million years, the changes we made to the land might be visible only in subtle patterns. This straightened river here, a deposit of unusual elements there. The rest would be overwritten by the slow processes that never stop. That's what makes the search for deep history so challenging. We aren't looking for intact artifacts, but for fragments that have survived in spite of everything working against them. And the older we look, the more we have to accept that the record will be incomplete, maybe hopelessly so. There are entire continents worth of history we will never know, not because the past is deliberately hidden from us, but because so much of it is gone in every meaningful sense. Even the ocean floor, which might seem like a vault of memory, is far younger than we imagine. The crust beneath the deep oceans is rarely older than 200 million years, constantly renewed as old seafloor is pulled back into the mantle at subduction zones. Anything that once rested there, no matter how well preserved, has been destroyed and recycled into the planet itself. Land can last longer, but it too is reshaped by time. Mountains rise and crumble. Rivers cut valleys. Continents drift, colliding and tearing apart, shifting coastlines and climates until what once stood is erased. This endless turnover is why the fossil record is full of gaps. Life was not absent during those times. it was simply not preserved. If the Earth is a library, it is one where shelves of books have been burned, rewritten, or rebound into other volumes. What we hold today are scattered chapters, often incomplete, sometimes so weathered that the original story is hard to read. Scientists know this well. They work with fragments, constantly weighing what has survived against what has been lost. A well-preserved fossil represents a rare coincidence of conditions: rapid burial, stable surroundings, protection from scavengers, and decay. The same would have to be true for any artifact of a civilization. It would need to be sealed quickly, hidden from erosion, spared from tectonic shifts, and locked away for millions of years. Even then, recognition would not be simple. A worked stone might be mistaken for a natural fracture. An unusual mineral deposit could be dismissed as the product of chemistry rather than craftsmanship. Without clear context, multiple clues pointing in the same direction, evidence could easily be overlooked or misinterpreted. That is why the idea of the planet's memory matters so much. It's not enough to imagine what an earlier civilization might have built. We must also imagine how those creations would have interacted with the forces of erosion, subduction, and decay over unimaginable spans of time. We must ask what could survive and in what form, and we must accept that most of it would not. The Earth remembers selectively. It preserves chemical traces in rock, tiny fossils in amber, delicate impressions of leaves pressed into mudstone. These fragments are precious, not because they give us a complete story, but because they give us any story at all. Everything else is gone, as if it never existed. That silence is the greatest reason we cannot be certain about what the Earth may have hosted before us. Its memory is long, but it keeps its secrets well. If there were others before us, beings who dreamed, built, and vanished, their presence would now be little more than the faintest of signatures, if that. The question is whether we've already passed over some of those signatures without recognizing them, or whether they're still buried, waiting for the right conditions to be uncovered. That possibility leads naturally to the next thought. If the planet has hosted intelligence before, what kind of life might have been capable of it? When we picture the age of reptiles, most of us imagine dinosaurs as they appear in museum displays or films, towering predators with teeth like knives, long-necked giants moving through swamps, herds of plated herbivores swaying their tails like living fortresses. It's a view dominated by size and spectacle, a world where brute strength seems to rule. But the reign of the reptiles lasted for more than 160 million years, and in all that time, there was room for much more than size. There were niches for creatures that were small, quick, and clever, for hunters that relied on precision as much as power, for opportunists that could adapt to changing environments in ways that hint at something more than instinct. If we're going to wonder about a civilization that predates our own, the Mesozoic era, when dinosaurs were at their peak, is one of the first places curiosity turns. Not because we imagine city-building tyrannosaurs, but because evolution had time to explore countless forms during that span. The variety of life was extraordinary. There were flying reptiles that could cross whole seas, aquatic reptiles that ruled the oceans, and land dwellers that ranged from the size of a chicken to the length of several buses. Among them were small, lightly built species with brains proportionally larger. Thanthos, of their enormous relatives. Brain size alone doesn't determine intelligence, but it offers clues. In modern animals, there's a rough pattern. Species with higher brain-to-body ratios often show more complex behaviors, better problem solving, and more adaptability. Some of the smaller theropod dinosaurs, especially those closely related to birds, had relatively large brains for their size. They had keen vision, good coordination, and in some cases, evidence suggests they may have hunted cooperatively or cared for their young. These are the kinds of traits that, given enough evolutionary time, could form the basis for more advanced social structures. Birds, after all, are living dinosaurs, and some of them, like crows and parrots, are capable of remarkable problem solving. They use tools, recognize themselves in mirrors, and pass learned behaviors through generations. If modern birds can do this, it's not impossible that their ancestors might have had similar capacities, perhaps even greater in some lineages that are now extinct. The problem is that intelligence, in the sense we mean it here, leaves little direct trace in the fossil record. A fossil can show us the shape of a skull from which we can infer brain size and structure, but it can't show us how an animal thought, communicated, or planned. We have to look for indirect clues, evidence of social behavior in trackways, signs of nesting colonies, patterns of distribution that suggest migration or complex hunting strategies. These hints exist for some dinosaur species, but they're far from conclusive. It would have required not just cleverness, but the ability to manipulate the environment in lasting ways. That raises the question of anatomy. Dinosaurs, as far as we know, didn't have manipulative limbs like our hands. Some had grasping claws, and their descendants, birds, have dexterous beaks and feet. But crafting tools in the way humans do might have been challenging. That doesn't mean it was impossible. They might have developed technology suited to their own bodies, arranging materials with their feet and mouths, using natural features of the landscape as tools, or even working cooperatively to build structures. If such a civilization had existed, what would it have looked like? It's tempting to imagine settlements built in sheltered valleys or along rivers, perhaps made from plant materials, mud, or stone. They might have created elevated platforms to avoid floods or constructed nesting grounds that were maintained and expanded over generations. Their art, if they had it, could have taken forms we wouldn't immediately recognize. Arrangements of feathers, shells, or colored minerals, patterns, scratched into the ground or carved into soft surfaces. The difficulty, as always, is preservation. Organic materials like wood and plant fibers decay quickly, and even stone structures can be erased over millions of years. In the time since the last non-avian dinosaurs lived, continents have shifted, mountains have risen and worn away, and oceans have opened and closed. Anything they built would have had to survive all of that, and the chances are slim. We might never know if such structures existed unless they left behind more durable signs, such as changes in the distribution of certain minerals or evidence of large-scale environmental modification. And yet, the reign of the reptiles was long enough to allow for many experiments in evolution. Our own lineage has produced tool-making intelligence only once, but that's in a fraction of the time dinosaurs were around. It's not unreasonable to think that somewhere in that vast span, a lineage could have developed not just intelligence, but culture. Whether it happened or not is another matter, but the possibility can't be entirely dismissed. It's also worth remembering that we tend to see dinosaurs as primitive compared to mammals, a bias that comes from the fact that mammals dominate the world now. But during the Mesozoic, mammals were the small, furtive creatures living in the shadows. Dinosaurs were the ones filling almost every niche on land. If intelligence were to arise during that time, it would make sense for it to come from the dominant group, and if it did, its legacy might live on, not in ruins, but in the behaviors of their descendants. The birds that still surprise us with their problem-solving and adaptability. Even without a civilization, the age of reptiles shows us that intelligence can arise in unexpected ways, in forms very different from our own. It's a reminder that the capacity for complex thought isn't tied to any one body, plan, or ecological role. It depends on opportunity, on the right combination of traits, and on the time to let those traits develop into something more. The thought of an intelligent, culture-building dinosaur lineage invites us to expand our imagination beyond the familiar. It asks us to consider what kinds of civilizations might develop under conditions we've never experienced, with bodies and senses, unlike ours, in environments that no longer exist. It also leads naturally to another possibility, one that doesn't involve land at all, but the vast and largely hidden world beneath the waves. If the land is a restless and forgetful place, constantly shifting and erasing itself, the oceans are an even deeper mystery. They cover most of the planet, hide its tallest mountains and deepest valleys, and hold within them ecosystems that are still largely unknown to us. For as much as we've mapped the continents and cataloged life on the surface, the sea remains a place of unanswered questions. We've explored only a small fraction of its depths in person, and much of what lives there never comes close enough to the surface for us to see. If there had ever been a civilization beneath the waves, its story might still be hidden in the places we've barely begun to look. It's an idea that feels almost inevitable once you consider the timescales involved. Life began in the oceans, long before it found its way onto land. Complex, multicellular organisms thrived there for hundreds of millions of years before the first forest appeared. Even after land-based ecosystems grew and flourished, the seas continue to support their own evolutionary experiments, some of them producing animals with remarkable intelligence. Today, dolphins, whales, and certain species of octopus show cognitive abilities that rival those of many land mammals. They solve problems, communicate in complex ways, use tools, and in some cases pass learned behaviors down through generations. If intelligence could develop to that level in multiple marine lineages in the relatively short time since humans evolved, it's worth asking what could have happened if one of those lineages had been given tens of millions of years more to work. Would the oceans have been stable in some respects for vast periods? No glaciers scouring them clean, no tectonic uplift exposing their floors to erosion. They change in currents and chemistry, but there's always somewhere in them for life to persist. For an intelligent aquatic species, this could mean an unbroken stretch of time to develop technologies and cultures suited to their environment. The challenge for us trying to imagine such a civilization is that our concept of technology is based on fire, metal, and stone, things that are difficult or impossible to use underwater. But technology doesn't have to look like ours. A marine civilization might work with the materials available to them: shells, coral, volcanic rock, plant fibers, or even carefully cultivated colonies of living organisms. They might shape the seafloor, building shelters in caves or trenches, creating gardens of seaweed and algae for food, raising shellfish in protected areas. Their art could be patterns made of colored shells arranged in ways only visible from certain angles, or intricate coral structures grown over decades. Their communication might be based on sound, light, or even chemical signals traveling through the water far more efficiently than in air. Whales can communicate over vast distances with low-frequency sounds that carry across whole ocean basins. Bioluminescent organisms already use flashes of light to signal one another. An intelligent marine species could develop languages built from such systems, exchanging complex information without ever needing a written script in the sense we know it. The traces of such a civilization would be fragile. Organic materials decay quickly in the ocean, especially in warm, oxygen-rich waters. Coral and shell structures can last for centuries, but over millions of years they dissolve or are buried in sediment. Even the seafloor itself is young compared to the continents. As oceanic crust is created at mid-ocean ridges, it moves outward and is eventually subducted into the mantle, carrying anything built upon it down into heat and pressure that erases all record. The oldest ocean floor on Earth today is about 200 million years old, a blink in geological time. That means any ocean-based civilization older than that would have its home territory literally destroyed, recycled into new crust, but that doesn't mean all traces would vanish. Some could survive in coastal regions that were once under shallow seas, now lifted above the water by tectonic activity. We already find marine fossils in desert cliffs and mountain ranges, reminders of ancient oceans that no longer exist. If a marine civilization had built structures in such shallow zones, some fragments might still be there, buried under layers of sediment, waiting to be uncovered. Chemical evidence might be another clue. A large-scale alteration of the marine environment, whether through farming, construction, or energy use, could leave traces in sediment chemistry. We've already seen how human activities leave such marks. Changes in nitrogen levels from fertilizer runoff, heavy metal deposits from mining and industry, microplastics accumulating in sediments around the globe. These are the kinds of signals our own civilization is leaving behind. Over time, most will be buried, but some will persist in deeper layers of rock, quiet markers that future geologists could read as evidence that something once altered the oceans in ways nature alone could not explain. There is also the possibility of fossilized remains. Bones, shells, or other durable body parts can survive if buried quickly in loxygen environments, such as deep-sea sediments or anoxic basins where decay slows to a halt. If an intelligent marine species had such resilient structures, a few might have entered the fossil record. The challenge would be recognition. Without a modern comparison, their anatomy might not be understood as belonging to an intelligent, tool-using being. They could simply be cataloged as an unusual, extinct animal. their true capabilities never suspected. Thinking about an ocean empire shifts our assumptions about what civilization requires. We usually link the concept to land, agriculture, permanent settlements, monuments, but in the sea, resources exist in 3 dimensions, spread through a volume rather than across a surface. Mobility could matter more than permanence. Seasonal or migratory patterns might take the place of fixed borders and cities. Such a culture might gather in temporary hubs during certain times of year, then disperse into smaller groups. There, history might be carried entirely in memory, in song, or in inherited patterns of learned behavior, leaving almost nothing behind for us to discover. It is also possible that an aquatic civilization would have touched the land in some way, especially if it included amphibious species or individuals able to spend time on shore. They might have harvested resources from beaches, cliffs, and tidal zones. They might even have shaped coastlines to suit their needs. Those interactions could leave more durable traces, unusual stone arrangements, altered waterways, or shell middens far larger and more complex than those produced by non-intelligent species. Over millions of years, these could be buried in coastal sediments, waiting for someone to recognize their significance. The oceans have always been places of both abundance and danger. Food can be plentiful, but so can predators. Storms, currents, and shifting temperatures can reshape entire regions. For an intelligent marine species, survival would mean learning not just the patterns of the sea, but how to anticipate and adapt to its changes. That knowledge passed through generations could become a foundation for culture. And just as we see with whales and dolphins today, the social bonds in such a species could be deep and lasting, with individuals cooperating, teaching, and caring for one another in ways that go far beyond instinct. If such a civilization had existed, its disappearance might be even harder to detect than one on land. The very environment that sustained it would also conceal its passing. Storms would dismantle their works, currents would scatter them, geological processes would swallow their homes. All that might remain is a faint chemical anomaly in a layer of rock that once formed on the seabed, or a few scattered fossils that no one recognizes as anything more than another extinct marine species. And yet the ocean is patient. It has hosted life since the beginning, and will likely do so long after the continents have shifted into shapes we wouldn't recognize. It has the capacity to nurture intelligence, as it has done more than once in our own era. If intelligence can rise again and again in the relatively short span we've been here, perhaps it has risen before in forms we can only guess at. From here, the path of speculation leads back to the land, to the other possible candidates for an early civilization. Creatures that might not have dominated the earth as visibly as dinosaurs or filled its depths like marine empires, but that could have found their own way to complexity before we ever arrived. The creatures that dominate our imagination when we think about prehistory are often the ones that left the biggest bones or the most striking silhouettes. Dinosaurs, mammoths, saber-toothed cats, these are the headline names. But Earth's past wasn't only shaped by giants. Much of its story was written by smaller, less conspicuous animals, the ones that fill the spaces between the spectacular and the ordinary. And among those, it's possible there were species that reached levels of intelligence and cooperation that never made it into our fossil Hall of Fame. These are the ones we might call the forgotten builders. They may not have been the rulers of vast ecosystems or the apex predators of their time. Instead, they could have lived in tightly knit groups, perhaps in sheltered environments where resources were predictable and safe enough to allow for experimentation. Intelligence doesn't always evolve in the spotlight. Sometimes it grows quietly, in the margins, in places where survival allows time for learning, teaching, and creating. Looking at life today, we can see that the seeds of civilization-like behavior exist in more than just humans. Beavers alter rivers and landscapes to create ponds for their lodges. Certain birds build complex nests, weaving them from multiple materials in ways that show individuality and even regional styles. Some primates form intricate social hierarchies and pass down techniques for using tools. Ants and termites construct elaborate cities, underground or in towering mounds above it, complete with ventilation systems and specialized chambers. None of these crossed fully into what we would call civilization, but they hint at how environmental pressures and social behavior can create the conditions for something more. If we imagine a forgotten builder in the deep past, it might have combined several of these traits: an ability to manipulate the environment, a capacity for problem solving, and a culture of passing knowledge from one generation to the next. Such a species might not have needed to dominate every corner of the globe. It could have thrived in a limited range, adapting its surroundings to suit its needs in ways that left little trace millions of years later. The physical form of these hypothetical builders could have been almost anything. They might have been small mammals with nimble paws, capable of shaping materials with precision. They could have been large birds with strong beaks and feet, able to transport and arrange objects. They might even have been reptiles or amphibians with dexterous limbs, working in damp or forested environments. The common thread would have been an ability to use their bodies to change their surroundings intentionally and repeatedly. What they built might not resemble our architecture. It could have been made entirely of organic materials, woven shelters from plant fibers, dugout chambers reinforced with clay, or raised platforms from interlocking branches. These wouldn't have lasted long once abandoned, especially in wet climates where rot and insects work quickly. Over millions of years, even the soil patterns they left behind could be erased by erosion, flooding, and the slow churn of geological processes. The challenge in finding traces of such a species is the same as with any ancient civilization. Most of what we might look for would be gone. We would have to search for indirect signs. If their building practices altered the flow of water, we might find unusual sediment patterns or layers rich in certain minerals. If they cultivated plants, the fossil pollen record might show a sudden and localized abundance of a species far outside its normal range. If they hunted or gathered in particular ways, there might be distinctive patterns of animal remains in ancient deposits, but even these signs can be ambiguous. Nature is full of processes that mimic the effects of intelligent activity. Rivers shift course naturally, carrying minerals into new areas. Wind and animals can spread plant seeds far from their original habitats. Predator kills can accumulate in spots that mimic the refuge piles of a hunting society. Separating the deliberate from the accidental is one of the hardest tasks in archaeology. And the further back in time we go, the more difficult it becomes. There's also the question of how we define and perceive intelligence. Much of our evaluation is shaped by human standards, valuing traits that resemble our own language, symbolic art, or the creation of complex tools. But intelligence may have many other forms that leave no lasting artifacts. A long-forgotten builder species might have relied on elaborate oral traditions, memory-based mapping of landscapes, or seasonal gatherings to transmit knowledge forms of culture that disappear entirely once the species itself vanishes. Their most impressive achievements could have been fleeting, existing only in the minds of their members and lost forever with them. It's possible that some lineages we now regard as ordinary animals were once capable of far more than we realize. Evolution does not progress in a straight line toward complexity. It is a branching, unpredictable process where traits appear, vanish, or resurface in entirely different forms. A species can develop sophisticated intelligence and later lose it if it no longer offers a survival advantage. If such a civilization existed, the traces might be so subtle that we would not even know where to begin looking. We must also imagine the possibility of multiple intelligent species coexisting or competing for resources. Fossil evidence shows us that at many points in Earth's history, multiple large species lived side by side. If one species was more adaptable, better suited to climate shifts or environmental pressures, it could have outcompeted the others, erasing them not only from the landscape but from memory itself. Even in our own time, cultures vanish rapidly when confronted with competition, environmental upheaval, or disease. Languages disappear in a single generation. Centuries of accumulated knowledge can vanish overnight. Scale that to millions of years, and an entire civilization, particularly one small or regionally confined, could vanish almost entirely, leaving only the faintest echo in the geological record. If such builders existed, they may have adapted to their world in ways unimaginable to us. They could have domesticated animals, now extinct, cultivated plants that no longer grow, or reshaped landscapes in subtle, unrecognizable ways. Their success may have been remarkable in its own right, even if the outward appearance of their civilization bore no resemblance to ours. In their time, they might have thrived, innovated, and left marks we can barely perceive, scattered as whispers across the Earth's long, deep memory. The thought of these forgotten builders invites a kind of humility. It reminds us that the history of life is far bigger than the human story, and that intelligence and culture may have bloomed in many forms before us. The world we know is not the only world that has ever been possible, and the ways of life we take for granted are just one branch of a much larger tree. Speculating about them also pushes us to think differently about how we search for the past. Instead of only looking for stone monuments or metal tools, we might also look for subtler patterns, changes in soil chemistry, unusual concentrations of certain plants or animals, or geological features that don't quite fit the local natural processes. We might train ourselves to see the possibility of deliberate design in places where we'd otherwise see only chance. And if we accept that such a species could have existed on land without leaving obvious ruins, it becomes easier to imagine that similar stories might have played out in other environments. On mountain slopes, in desert oases, in places where the landscape itself was their greatest tool, which naturally leads us toward considering not just the materials they might have used, but the science of detecting traces so faint that they can barely be distinguished from the background noise of the Earth's own history. When you think about the physical remains of the past, it's easy to picture the obvious ones: bones in a museum display, stone tools in a glass case, fragments of pottery with their painted patterns still visible. But the truth is, most of the history of life isn't preserved in objects like these. It's written in the smallest of details, buried deep in the layers of the earth, where the sediment itself is the archive. Every grain of sand, every particle of silt, every layer of clay is a page in a book that took millions of years to write. And just like any book, some pages are faded, some are smudged, and some are missing altogether. Sediment is everywhere. It forms in rivers and lakes, on the seafloor, in deserts, and at the base of mountains. It's made from the broken down pieces of older rocks, the remains of plants and animals, the dust carried by wind or washed by rain over time. Layer after layer builds up, burying whatever falls into it. If conditions are right, if the material is quickly covered and protected from disturbance, those layers can last for millions of years, holding on to the tiniest clues about the world that created them. To the trained eye, these layers can tell stories. A coarse gravelly deposit might mean a fast-flowing river once cut through the area. Fine, uniform silt could point to a calm lake or a slow-moving part of the sea. Alternating light and dark bands might reflect seasonal changes, like the annual rings of a tree. Even without a single fossil, sediment can reveal whether the climate was warm or cold, wet or dry, stable or chaotic. And sometimes the sediment carries more than just a general impression. It can hold microscopic remains, tiny shells from plankton, grains of pollen from ancient forests, or spores from long-vanished ferns. These particles are incredibly durable, and they can tell us which plants and animals were present when the layer was laid down. A sudden spike in one type of pollen might suggest that a plant became unusually common in that region. A sharp drop could mean it disappeared, perhaps due to a shift in climate, a natural disaster, or the arrival of something new that changed the balance of the ecosystem. For anyone searching for signs of a lost civilization, this is where the trail often leads, not to grand ruins or intact artifacts, but a subtle, layered changes in the environment that could hint at human-like influence. We know from our own history that agriculture, deforestation, mining, and pollution all leave measurable marks in sediments. Large-scale farming changes the mix of pollen in the soil. Metalwork can leave traces of lead, copper, or mercury that persist long after the smelters have cooled. Even our modern plastic waste is settling into sediments around the globe, forming a future geological layer that will be unmistakable to whoever or whatever studies it millions of years from now. The problem, of course, is that natural processes can create many of the same signals. Volcanic eruptions can spread heavy metals far and wide. Droughts can wipe out certain plants and give others room to spread. Shifts in ocean currents can change the chemistry of sediments over huge areas. A layer of dark material, rich in carbon, might point to widespread burning. But whether that burning was the result of a lightning-sparked wildfire or intentional land clearing by an intelligent species isn't easy to determine. This is why scientists who work with sediments often approach them the way detectives approach a crime scene. One piece of evidence isn't enough. You look for patterns for multiple clues that point in the same direction. If a layer of sediment shows an unusual chemical signature, you ask, is there a matching change in pollen? Are there signs of soil disturbance consistent with farming or construction? Do fossilized remains of animals show a sudden shift in diet or habitat that would make sense if humans or human-like beings were altering the landscape? Even when patterns do emerge, certainty is rare. The further back in time you look, the more the details blur. A single layer of sediment might have taken centuries to form, mixing together events that happened years apart. Over millions of years, pressure and chemical changes can alter the composition of the material, erasing or distorting the original signals. And because sediments are constantly being moved and redeposited, a single discovery might have traveled far from where it originally formed. Still, the potential is there. If an ancient civilization had engaged in activities like large-scale farming, metallurgy, or energy production, some trace might survive in sediments, particularly in areas that were geologically stable for long periods. The key would be finding those stable regions and reading their layers with enough precision to distinguish the extraordinary from the ordinary. In our own time, we've already seen how dramatically human activity can reshape sediments in places. Near industrial centers, layers laid down over just the past 100 years are full of chemical markers. Everything from leaded gasoline residues to radioactive isotopes from nuclear testing. Far from cities, in remote lakes and polar ice, the sediment still carry the fingerprints of human industry, borne on winds and currents that reach even the most isolated places. These are changes so widespread that they will be visible in the geological record for tens of millions of years if we can leave such a strong mark in such a short time. It raises the question, what would the equivalent layer from a past civilization look like? If they were industrial, the sediment might carry traces of their energy sources, whether that was burning biomass, smelting metals, or something entirely unfamiliar to us. If they altered landscapes for agriculture, the pollen record might show sudden lasting changes in plant composition. If they lived primarily along coasts or rivers, the sediments in those regions might carry the densest concentration of clues. There's also the intriguing possibility that a past civilization might have used materials we don't recognize as artificial. Our own sediments now contain synthetic compounds, plastics, for example, that did not exist in nature before we made them. Millions of years from now, these might survive as distinctive microscopic particles, even if they no longer resemble the original objects. A non-human civilization could have developed its own unique materials, which might now appear to us as unusual but natural mineral inclusions. Without knowing what to look for, we could easily overlook them. Reading sediments for signs of the past requires patience and caution. Each core sample, each exposed cliff face is a puzzle with missing pieces. The challenge is not only to gather as many clues as possible, but to ask the right questions about what they mean. Are we seeing the effects of climate, geology, biology, or something else entirely? Are we looking at a moment of change in the natural world or the legacy of intelligent action. The deeper you go into the sediments, the more you realize how much they hold and how much they hide. They are both witness and participant in the planet's story, recording what happens even as they are shaped by it. If a past civilization left its mark here, it would be like a ghost in the record, faint, partial, and easily mistaken for something else. Finding it would require not only technical skill, but the willingness to see intelligence where we're accustomed to seeing only nature. And if such a ghost were ever recognized for what it was, it would force us to rethink everything about our place in the planet's history. We would no longer see ourselves as the first to alter the Earth in a lasting way, but as just one in a line of builders, separated by spans of time so great that only the sediments remember, which leads to another line of investigation, one that doesn't focus on the physical shape of past life, but on the chemical signatures they might have left behind, hidden in the very fabric of the Earth's oldest materials. If you think about it, everything we do leaves a chemical trail. Every fire produces smoke rich in particular compounds. Every factory releases byproducts into the air, the soil, or the water. Every mine shifts the balance of minerals in the ground. These traces don't just vanish. They move through the environment, settle into sediments, and sometimes lock themselves into the geology for spans of time far beyond human history. Even natural processes, volcanoes erupting, rivers flooding, glaciers grinding, leave behind their own distinct chemical signatures. The Earth is layered with these markers, each telling part of the story of what happened and when. That's why scientists looking for signs of a long-lost civilization often think about chemistry as much as about fossils or artifacts. A chemical signature can survive where physical structures are destroyed. It can travel farther than bones or tools. It can outlast even the species that made it, sitting quietly in a rock layer until someone comes along to measure it. The trick is knowing what counts as unusual, what kind of pattern is unlikely to be the result of purely natural forces. We've already created such patterns ourselves. The Industrial Revolution left measurable spikes in certain heavy metals like lead, copper, and zinc in soils and sediments across the globe. The mid-10th century left an even more striking layer: the fallout from nuclear testing, which scattered radioactive isotopes into the environment worldwide. These isotopes have half-lives of thousands to millions of years, meaning they will remain detectable for far longer than our buildings or even many of our fossilized bones. Future scientists, whether human or something else entirely, will have no trouble identifying the layer that marks our time. But suppose you were to go looking for an older version of such a chemical anomaly. You wouldn't expect to find the exact same pattern. A different civilization might have used energy sources we never considered or processed materials we've never touched. Instead, you'd be looking for deviations, combinations of elements or isotopes that are rare in nature, but common in certain industrial or technological activities. You'd also have to rule out natural events that could produce similar results, like volcanic eruptions or meteor impacts. Volcanoes, for example, can release large amounts of sulfur, mercury, and other elements into the environment. But volcanic deposits tend to have specific ratios of these elements, and they are often concentrated near the eruption site. A civilization's emissions, on the other hand, might be spread across vast distances, carried by winds and water currents, showing up in multiple unconnected places at the same time. Similarly, meteor impacts can scatter rare metals like iridium, but they also leave unmistakable physical evidence like shocked quartz or a crater that can distinguish them from other sources. Another possible chemical fingerprint is the large-scale alteration of carbon isotopes. Plants, animals, and fossil fuels all have characteristic ratios of the lighter and heavier forms of carbon. When humans burn fossil fuels, we change the balance of these isotopes in the atmosphere and oceans, a shift that is recorded in tree rings, ice cores, and marine sediments. If a previous civilization had burned large quantities of fossil carbon, whether coal, oil, or some other form, the isotopic record might show a similar pattern. The difference would be in timing, depth, and context. A spike in carbon isotopes without evidence of a natural cause, like massive volcanic activity, could be a hint that something unusual happened. Mining can also leave a distinct mark, extracting metals from or often concentrates certain elements in waste piles or tailings. Over time, these can leach into the soil and water, creating localized chemical anomalies. If those anomalies are preserved in sedimentary layers, they might survive for millions of years. An unusually high concentration of a metal that's rare in the surrounding rock could be one of the clearer signs of deliberate extraction. The challenge is finding these anomalies in the first place. They might be buried deep beneath newer layers, or hidden in regions that haven't been studied in detail. It's also worth thinking about what kinds of materials an earlier civilization might have created that nature does not. We've made plastics, synthetic rubbers, and a variety of polymers that simply didn't exist before. Many of these materials are resistant to decay, at least on human timescales, and they tend to break down into tiny particles rather than disappearing completely. Over millions of years, they might undergo chemical changes, but their basic composition could still be recognizable as artificial. If a previous civilization, had developed its own equivalents of synthetic compounds, chemicals, unlike anything produced naturally, they could serve as unmistakable markers, provided they survived in a recognizable form. One of the fascinating aspects of chemical fingerprints is how they often intersect with other types of evidence. A shift in pollen within a sediment core might coincide with an increase in certain metals, hinting that land clearing and mining occurred simultaneously. A spike in carbon isotopes could align with layers of ash, pointing to widespread burning. These correlations strengthen the case, suggesting coordinated, purposeful activity rather than unrelated natural events. Of course, the absence of such evidence does not prove that no civilization ever existed. A society living in balance with its environment, relying on renewable resources, avoiding large-scale extraction or combustion, might leave virtually no detectable chemical trace. Its legacy could dissolve into the background noise of natural variation, indistinguishable from baseline planetary patterns. This is what makes the search both challenging and intriguing. The signs we seek could be as glaring as a neon light or as subtle as a faint smudge in the data, demanding careful attention and interpretation. Adding to the complexity is the uneven preservation of the chemical record. Some environments excel at locking in these signatures. Deep ocean sediments, lake bottoms, and ice cores can maintain stable records for hundreds of thousands, even millions of years. Others are constantly disturbed, erasing traces almost as soon as they are created. Floodplains, shorelines, and shallow soils are in perpetual motion, mixing old and new material. A civilization residing primarily in such dynamic zones might leave very little behind, even if technologically sophisticated. Then comes the challenge of recognition. Even if a chemical anomaly is found, scientists must determine whether it is truly significant or simply a quirk of the natural world. Sometimes it's a slow contraction, fewer settlements, reduced trade, loss of specialized skills, traditions fade, infrastructure deteriorates, and knowledge once common becomes rare. In human history, we see examples of societies that shrank to a fraction of their former size, surviving in isolated pockets while the rest of their territory was reclaimed by nature. For a civilization millions of years in the past, the eventual disappearance of those last holdouts would erase the final living memory of what they had built. The fall might also have been triggered by events entirely outside their control. A large asteroid impact could have caused a global climate shift. Massive volcanic eruptions could have filled the air with ash and sulfur, cooling the planet and disrupting ecosystems. Tectonic movements could have submerged entire land masses or transformed coastlines beyond recognition. In such cases, even a well-managed civilization could have been overwhelmed. Whatever the cause, the end of a civilization marks the beginning of its transformation into history, and given enough time into mystery, the physical traces begin to fade. Buildings crumble, tools corrode, art decays, organic materials vanish quickly, while even the most durable structures are eventually buried, broken, or eroded away. In the deep timescales we're considering, the vast majority of their works would not survive. What remains might be scattered, fragmentary, and ambiguous, but even in its absence, the memory of their existence could echo in the world they left behind. Changes to ecosystems, genetic legacies in domesticated species, shifts in the distribution of certain minerals or chemicals. These could persist long after the civilization itself was gone. The echoes might be faint, but they would still be there for those who know how to listen. And if those echoes are faint now, it may be because they were buried under something even larger. For in the deep past, the Earth has experienced moments when life itself nearly vanished, when the slate was almost wiped clean, leaving only the survivors to carry on. If a civilization existed before us, it might have met its end in one of these cataclysmic events, disappearing not just from history, but from the very fabric of the biosphere. There's a strange kind of reflection that happens when we think about the deep past. We start with the idea that we're looking backward, studying the traces of what might have been, but at some point, without even realizing it, we find ourselves looking at our own world, our own moment in history through the lens of what we imagine could have happened before. It's as though the ancient Earth is holding up a mirror, and in the faint hypothetical outlines of a long-vanished civilization, we see shadows of ourselves. In that mirror, the timelines stretch and fold in ways that make the present feel small. You imagine another species walking the Earth, or swimming in its oceans, or gliding through its skies millions of years before our ancestors were even a thought in evolution's mind. They had their own beginnings, their own periods of struggle and innovation, their own mastery of the environment. And maybe they also face the same kinds of challenges we do. Resource limits, environmental shifts, internal conflicts, the gamble of technological change. It's easy to imagine that some of their debates, their fears, and their hopes might have felt familiar to us, even if every detail of their culture was alien. This way of thinking is more than just idle curiosity. It's a way of breaking free from the illusion that our story is entirely unique. We often treat our current moment as the center of history, as though intelligence and technology are rare miracles that have only just emerged. But if you allow yourself to picture others who came before, you have to face the possibility that civilizations are not one-time events. They could be recurring patterns in the life of a planet, rising and falling over millions of years each, one as confident in its permanence as we are now. That realization can be unsettling. It shrinks the ego a little, and it makes the future feel less certain. If someone else stood where we stand now, if they thought they had solved the puzzle of survival and yet they are gone, then what does that say about our chances? It doesn't have to be a fatalistic thought. It can be a humbling one, a reminder that the survival of a civilization depends on more than intelligence or technology. It depends on balance between growth and sustainability, between ambition and caution, between the needs of the present and the needs of the future. The mirror also works in the other direction by thinking about how a past civilization might appear to us now, fragmented, incomplete, often indistinguishable from the background. We can better imagine how we might appear to whoever comes after us. What would they see in the geological record of our time? How much of what we think defines us would still be visible? And if our own signals are eventually reduced to a few strange layers of sediment and scattered chemical traces, would future minds be able to guess at the full complexity of our world? This thought exercise can shift how we view our current impacts. A layer rich in plastics, isotopes, and altered carbon ratios might someday be the most recognizable sign of our existence, even if our cities and cultures have long vanished. That's the case, then our most enduring legacy might not be our art, our science, or our technology, but the footprint we've left in the physical planet itself. The same could have been true for the civilization we imagine in the past. Perhaps what survives of them is not their greatest achievement, but their most lasting alteration to the earth. Of course, a mirror can distort as much as it reflects. We project our own values and concerns onto this imagined past, shaping it into something that feels familiar enough for us to contemplate. It's possible that a pre-human civilization would have been so different from us in biology, psychology, and social structure that our comparisons barely make sense. Their concept of progress might have been entirely unlike ours. They might not have thought in terms of expansion, accumulation, or domination of nature. They might have measured success in cycles rather than lines, in balance rather than growth. If so, then their rise and fall might not follow the patterns we expect at all. Still, even if the details differ, the larger rhythm of emergence, flourishing, and decline could be universal. That rhythm is built into the nature of living systems, which thrive within certain conditions and falter when those conditions change too far or too fast. It's the same for forests, coral reefs, and civilizations, whether human or otherwise. The conditions for life are always shifting and every adaptation is temporary. When you think of the deep past in this way, the boundaries between imagination and science blur. We don't have direct evidence of another civilization before ours, but we do have evidence of the forces that shape and erase civilizations. We know how landscapes change, how climate can turn from stable to volatile, how resources can be exhausted. We know how fragile our own systems can be when pushed too far. That knowledge doesn't prove there was someone before us, but it tells us that if there had been, their fate might have been determined by the same pressures that will one day test us. Looking into this mirror also reminds us that time itself is the ultimate editor. It cuts away most of the details, leaving only a few fragments for the future to interpret. In the case of our imagined predecessors, that editing has been brutal. Tens or hundreds of millions of years of erosion, subduction, chemical change, and biological recycling. If they were here, almost all traces are gone. The same will happen to us. The question is whether the fragments that remain will tell a story of survival, of adaptation, or of collapse. There's something strangely comforting about that perspective. It places us in a long continuum, not as a singular pinnacle of evolution, but as one expression among many. It doesn't diminish our achievements, but it does frame them as part of a larger, older pattern. And in doing so, it invites us to think more carefully about what we choose to leave behind, not just in terms of material impact, but in terms of the kind of world we create for those who might follow. If we could reach through that mirror and see the civilization we imagine, perhaps we would learn lessons they learned too late. Or perhaps they would learn from us, watching to see whether we managed to navigate the challenges they could not. Either way, the reflection forces a question. If the pattern of rise and fall is written into the nature of civilizations, is there a way to step outside it? Or is the cycle as inevitable as the turning of the earth itself? And if it is inevitable, then perhaps the most lasting connection we could have with a civilization from deep time is not one of direct contact, but of shared experience. Two different societies, separated by millions of years, both walking the narrow path between flourishing and fading, each unaware of the other, yet bound by the same rules of survival. When we talk about the possibility of other civilizations in Earth's deep past, the idea often feels like an isolated thought experiment. But the more you look at the rhythms of life over hundreds of millions of years, the more it starts to seem like a question about patterns rather than one-off events. Because if intelligence arose once in us, why should it have been the first and only time? And if it has happened more than once, what if there's a cycle to it? A repeating emergence of minds capable of shaping the planet in deliberate, large-scale ways. Intelligence itself is not the same as civilization. The animal world is full of examples of creatures that demonstrate remarkable problem-solving skills, memory, and adaptability without ever building cities or industries. Octopuses can navigate mazes and use tools. Crows make hooks out of twigs to fish food from crevices. Elephants have complex social lives and seem to mourn their dead. None of these species has created a global infrastructure, but they show that intelligence in the raw sense is not rare. It evolves when it serves a purpose. Civilization, though, is something else. Is intelligence applied to long-term collective projects? It's the coordination of large groups toward shared goals, the development of technologies that compound over time, the ability to manipulate the environment far beyond what an individual could do alone. That combination, intelligence plus cooperation plus technology, is much rarer, at least in the fossil record we know. But rarity is not the same as impossibility. On Earth, complex life has been around for over 500 million years, and in that span, there have been multiple bursts of evolutionary innovation. Whole new body plans appeared. During the Cambrian explosion, land plants transformed the atmosphere. Vertebrates moved from water to land, and then, in some lineages, back to the water again. Flight evolved independently in insects, pterosaurs, birds, and bats. Each of these transformations happened not once, but multiple times in different forms and with different species. So why not civilization? It may be that given enough time, the combination of intelligence, cooperation, and technology emerges again and again, just as flight or vision does. The path might look different each time, shaped by the particular environment and evolutionary lineage, but the end point, a species capable of reorganizing the world around it, could be a recurring phenomenon. If that's the case, then what we're experiencing now is not unique in kind, only in detail. We might be the most recent in a series of civilizations that have risen, flourished, and vanished, each leaving behind traces that grow fainter with age. And if the traces of our own time will one day be difficult to recognize, how much harder would it be to detect those of a civilization that lived tens or hundreds of millions of years ago? It's not hard to imagine a cycle like this playing out. Over and over, a new form of intelligence emerges, adapting to the world it finds. It discovers ways to manipulate its environment to increase comfort, security, and resources. As it grows in numbers and capability, it develops tools and infrastructure, spreads across different habitats, and alters the planet on a scale large enough to be seen from space. For a time, it thrives, but eventually it encounters the same limits: environmental shifts, resource depletion, internal instability, or catastrophic external events. Some cycles might end quickly in sudden collapses triggered by disasters too large to manage. Others might fade slowly, with populations dwindling and complexity unraveling over centuries or millennia. Either way, the outcome is the same. The civilization disappears, leaving the planet to recover and reset. After a long enough pause, the process begins again with a different species, a different set of tools, and a different cultural path. One reason this idea is difficult to test is that the cycles could be separated by immense spans of time. Between one civilization and the next, tens of millions of years could pass, enough for the continents to shift, climates to change completely, and nearly all physical traces to vanish. Even if a few scattered artifacts survived, they might be buried so deeply or altered so thoroughly that they would be indistinguishable from natural features. It's also possible that not every cycle produces a technological civilization as we define it. Some intelligent species might choose paths that minimize large-scale environmental impact, valuing stability over growth. They might never develop metallurgy or industrial power, not because they lack the ability, but because their cultural priorities lay elsewhere. Such civilizations might still rise and fall, but their footprints in the geological record would be even fainter, perhaps. invisible to any future observer. If cycles of intelligence do exist, they raise questions about what drives them. Is there something in the nature of evolution that makes advanced intelligence more likely over long periods of time? Or is it a rare convergence of accidents, a roll of the dice that doesn't come up often enough to form a true pattern? And if it is a pattern, does it follow a rhythm we could measure tied to planetary cycles like climate shifts, tectonic reorganizations, or extinction events? Looking at Earth's history, we can see moments when such cycles could fit. After each mass extinction, life rebounds in bursts of diversity and innovation. These are moments when entirely new kinds of organisms take over ecological niches, sometimes developing novel capabilities. If intelligence is one of the possible outcomes, then the aftermath of an extinction could be fertile ground for it to evolve. In that sense, catastrophic loss might not just end civilizations, it might set the stage for the next one. This possibility reframes our own place in time. If we are part of a cycle, then our story is connected to others we will never meet. We are living in the space between what came before and what might come after. The traces we leave will be the starting point, or the cautionary tale for some distant future intelligence. Whether they recognize us or not, we will be part of their world in the same way a hypothetical pre-human civilization might still be part of ours through the changes they left embedded in the planet. It also raises the unsettling possibility that cycles don't necessarily lead to cumulative progress. Just because one civilization rises after another doesn't mean each is more advanced than the last. The conditions of the world at the time could favor different strengths, different priorities, and different technologies. The cycle could be less like a ladder and more like a wheel, turning endlessly through variations on the same themes. If that's true, then intelligence might be less of a linear march toward a pinnacle and more of a recurring opportunity, one that can be seized or squandered, and which always comes with an expiration date. And in thinking about how such cycles might work, we can't avoid wondering what, if anything, survives between them. Could knowledge ever be passed from one to the next? Could traces of a past intelligence somehow influence the next to arise? Or does the slate always return to near blank, forcing each new civilization to start from scratch? The answer to that might determine whether cycles of intelligence ever lead to lasting change on a planetary scale, or whether they are simply passing waves in the longer ocean of Earth's history, leaving only faint ripples for those curious enough to notice. It's not a thought most people linger on for long. But imagining the world without us can be one of the most revealing exercises in understanding our place here, not just in the abstract, but in concrete detail. What would happen if, for reasons, natural or otherwise, our species ceased to exist overnight? The streets still full of cars, the lights still on in some places for a while, the skies still crossed by the faint lines of aircraft vapor. In that first day, the difference might not be visible from a distance, but the chain of events would begin immediately. Within hours, systems that depend on constant human oversight would begin to fail. Power grids would go down in sections as automated protections tripped without anyone to reset them. Some areas might hold on longer than others, thanks to backup generators or self-regulating infrastructure, but the overall decline would be steady. Nuclear power plants without engineers to monitor them would shut down as safety systems engaged, though the handling of spent fuel would pose hazards for decades to come. Satellites would continue to orbit for years, some for centuries, before atmospheric drag finally pulled them down. Within days, the signs of neglect would become harder to ignore. Water treatment plants would stop functioning, leading to contamination in rivers and reservoirs. Food in supermarkets and warehouses would begin to rot, feeding explosions in rodent and insect populations. Domesticated animals would be left to fend for themselves. Some would adapt, others would die out quickly without the structures we've built for them. The silence of human voices would be replaced by the sounds of other species expanding into spaces we once dominated. Over weeks and months, the natural reclamation would accelerate. Plants would begin to push through cracks in asphalt and concrete. Without maintenance, drains and gutters would clog, leading to flooding in low-lying areas. Wooden structures would start to decay, while steel would rust in the moisture of unventilated air. In some places, wildlife would return in dramatic numbers. Wolves in suburban streets, bears in abandoned neighborhoods, birds nesting in the empty frameworks of office towers. Years into our absence, entire urban landscapes would transform. Buildings with glass facades would crumble as weather, wind, and plant growth weakened their frames. Roads would fracture under the steady pressure of roots and seasonal temperature shifts. Bridges would fail without inspection or repair. The great landmarks of our time structures we assume will endure for ages would be brought down by the same slow forces that erase mountains over geological time. Here, though, the pace would be faster. Over mere decades, cities would dissolve into forests, wetlands, and grasslands, shaped by climate and geography. Rivers would reclaim their floodplains. Coastal regions would shift as tides and storms reshaped the shorelines. The remnants of our industries, steel plants, oil refineries, chemical factories, would rust, leak, and eventually be buried under sediment or swallowed by vegetation. Our tallest towers would become unrecognizable heaps of debris. Some traces, however, would endure far longer. Plastics, shielded from sunlight, could persist for hundreds or even thousands of years, breaking into fragments but not fully decaying. Glass, ceramics, and certain alloys might survive far longer, though scattered and degraded. Underground infrastructure tunnels, pipelines, foundations could persist for hundreds of thousands of years, protected from the worst of erosion. Yet even on these extended timescales, most of what defines our present world would vanish. Paper and digital media would disappear quickly without active preservation. Digital archives would degrade within decades. Stone carvings might endure for millennia, but eventually even they would wear away. Without someone to maintain context, even surviving fragments might become indecipherable. From a geological perspective, our most enduring legacy would likely be chemical. Carbon from fossil fuel consumption would remain in altered isotope ratios. For millions of years, layers containing plastics, fly ash from coal burning, and traces of synthetic compounds would form a distinct bound area, subtle but unmistakable signature that future geologists or future intelligences could detect. In this quiet, chemical imprint, the echo of our civilization would persist long after the visible world has been reclaimed by nature. These would be the telltale markers of a technological civilization. Even if all visible structures had vanished, if the planet continued turning without us for tens of millions of years, those markers would grow faint but not disappear entirely. In some ancient strata, there might be an anomalous layer, thin compared to the vast geological column, yet distinct, a sudden spike in carbon isotopes, the presence of long-lived synthetic molecules, microscopic fragments of industrial products. That might be all that remained of us, compressed into a band no thicker than a human hand. What's striking in this experiment is how quickly most of our physical presence would be erased. For all our concrete and steel, for all our sprawling cities and engineered landscapes, nature would reclaim the surface faster than we like to imagine. It would be the hidden, microscopic, and chemical changes that endured. And that, in turn, shows how plausible it is that if there were civilizations before us, their surface traces could have been wiped away just as completely. Thinking about our absence also forces a question. What kind of mark do we want to leave? Right now, we are actively shaping our future legacy, whether we intend to or not. The materials we use, the energy sources we depend on, the ways we interact with ecosystems. These decisions will determine what is visible to anyone studying the Earth long after we're gone. If the most durable evidence of our existence is environmental damage, our story might be read very differently than we would tell it ourselves. And there's another angle. The absence of us would not mean the absence of intelligence forever. Earth's history suggests that life rebounds from mass losses, often diversifying into new forms. In our absence, the ecological niches we occupy would open to other species, some of which might evolve higher intelligence over time. The cycle could begin again, just as we now wonder it might have before. Those future minds might one day look back, if they could, at the faint marks we left and wonder who we were, just as we now wonder about those who might have come before. There is something quietly reassuring in knowing that not every question has an answer. We are taught to think of unanswered questions as problems to solve, gaps in understanding to be filled in many cases. That is true. We build science and history on the desire to close those gaps. But when it comes to the deep past, especially the parts that might involve other long-lost civilizations, there is a certain peace in letting some questions remain open. It's not just about the romance of the unknown, though that is part of it. It's about recognizing that mystery shapes the way we see our place in the world. If we could map every corner of history, if we could account for every rise and fall, the past might feel like a closed book. Nothing left to discover, nothing left to imagine. An imagination, as much as data is, what keeps us curious. We can study our own trajectory in real time, noticing both the warning signs and the opportunities. If there is a way to extend the lifespan of a technological civilization beyond whatever natural limit the cycle imposes, this is the moment to find it. And if we are the first civilization, not part of any cycle, then our choices matter all the more. We might be setting the precedent for what an intelligent species can do with a planet. That is an enormous responsibility, whether we ask for it or not. In that version of history, the patterns we establish now could echo into whatever comes next, millions of years from now. If intelligence rises again, we could be the example that future minds remember or the cautionary tale they study. Right now is also the only place where the questions about past and future intersect. When we speculate about earlier civilizations, we are testing the boundaries of what is possible. Could intelligence evolve more than once? Could technology rise and fall without leaving obvious traces? These questions are about them, but they are also about us. They ask whether we are part of something larger or entirely on our own, whether our challenges are unique or shared. And by living in the present, we have the advantage of being able to act on those questions even without definitive answers. The present is where we can build records meant to last, not because we expect them to, but because we know how fragile evidence can be. It is where we can decide what knowledge is worth preserving and how best to preserve it. If the geological record is the only sure way to communicate across millions of years, we have the rare ability to shape that message intentionally, rather than leaving it as an accidental byproduct of our industrial footprint. That kind of agency is uncommon in the life of a species and easy to overlook. When we focus only on the immediate, where we are now is also a moment of incredible connection. We can communicate across the planet in seconds, share ideas instantly, and coordinate efforts at a scale no earlier society could have imagined. That network is fragile, dependent on infrastructure that would vanish without maintenance. Yet, while it exists, it is a tool for shaping our collective story. The decisions we make today are not isolated. They ripple outward faster and farther than at any other time in history. And yet, despite all this reach and knowledge, the present is full of limits. We cannot see every consequence of our actions, predict every shift in climate, every political change, every innovation or setback. We live in a blend of control and uncertainty, just as every civilization before us did. The difference is that we are aware of it, watching ourselves from within and from a distance at the same time. That perspective is a strength if we use it well, a distraction if we get lost in it. Living in this exact moment means holding two truths at once: that we are temporary and that we have influence. Temporary because no species lasts forever. Influential because, while we are here, we can alter the course of things. This combination can lead either to carelessness or to carefulness, depending on how we choose to see it. The deep path suggests that if we do not pay attention to that balance, the planet will eventually reset without us. Yet it also suggests that life is resilient, that recovery and renewal are part of its nature. Where we are now is a crossroads we can only fully recognize in hindsight. Future generations, whether human or something else, will see the shape of our choices more clearly than we can. They will know whether we extended our time in the cycle or cut it short. They will know whether we left behind a legacy of learning or of loss. As centuries turn into millennia, the outlines of our cities would blur. Streets would disappear beneath soil and leaf litter. Concrete highways would fracture under frost and root, breaking into fragments that scatter with the winds and rains. Parks, once manicured and orderly, would revert to wild landscapes. Trees would sprout through asphalt and concrete, spreading roots that pry apart foundations and walls. Bridges, monuments, and stadiums would collapse into jumbled heaps. Even monuments carved from stone would erode slowly under rain, wind, and freeze-thaw cycles. Buildings designed to scrape the sky would be reduced to mounds of rubble. Skyscrapers, Their steel frames, twisted and rusted, might last longer than their facades. But without maintenance, corrosion would win. Underground subways, basements, and bunkers might survive in fragmented, half-flooded states, their existence detectable only through subtle shifts in the soil or small anomalies in the rock record. Over tens of thousands of years, forests would spread across what were once cities. Wetlands would fill depressions in roads and plazas. Rivers and streams would meander freely, erasing the channels we carved. Coastlines would shift dramatically under tides, storms, and rising seas, swallowing harbors and erasing ports. Mountain regions would reclaim abandoned ski resorts and mining operations. Deserts would reclaim farmland and suburbs. Wind-blown sands covering evidence of our presence. Even the tallest structures, radio towers, wind turbines, and communication masts would bend and collapse under gravity and corrosion. Steel would oxidize, concrete would crumble. Solar panels, plastics, and glass might endure longer, but fragmented and scattered. The sheer bulk of human architecture would gradually be reduced to patterns barely discernible in aerial or satellite imagery, eventually merging with natural landforms. Underground pipes, cables, tunnels, and foundations would persist longer, insulated from weather, but corrosion, shifting soils, and earthquakes would eventually compromise them. The faint metallic and mineral traces could leave anomalies detectable in geological surveys, subtle signals of organized activity long gone. Our chemical legacy would persist far longer than our buildings. Carbon isotopes altered by fossil fuel. Consumption would mark a global boundary layer in sediments worldwide. Plastics, metals, synthetic chemicals, and fly ash from industrial processes would be preserved in layers of rock and soil. Microplastics could be embedded in deep marine sediments, tiny markers of activity that could endure for millions of years. Even if the landscape were reclaimed completely, the ocean would retain evidence. Nitrogen levels altered by fertilizers. Metals released into water systems. Persistent organic pollutants. These chemical fingerprints would slowly accumulate in sediment layers, frozen in time. Future geologists, or future intelligent species, might detect these as abrupt anomalies, distinct from the slow, natural variations of the Earth. Bones and shells of animals we domesticated, or species we drove extinct, might survive as fossils. Fish species introduced to new ecosystems could leave lasting traces in the genetic record or in skeletal remains, even without stone tools or cities. These subtle ecological shifts would stand as a record of intelligent intervention. Over millions of years, erosion, subduction, and tectonic activity would erase the surface evidence of our civilization almost entirely. Mountains grow and crumble. Rivers shift course. Ocean floors are recycled into the mantle. Entire continents drift and collide. Humanity's most permanent physical structures would be ground down, buried, or obliterated. Only chemical, isotopic, and microfossil records would remain, compressed into layers thinner than a fingernail in the geological column. These traces teach humility, reminding us that what matters is not only what we build, but how we interact with the systems that endure. Intelligence shapes, but the planet endures longer than any civilization. Ultimately, the record we leave will be partial, subtle, and open to interpretation. Future species may reconstruct us imperfectly, finding hints of ingenuity, adaptation, and impact. Even without fully understanding our lives, this is both caution and comfort. Intelligence is fragile, civilization impermanent, yet impact endures. Life will continue, cycles will repeat, and the faint traces of each civilization will be read by those who follow. Our presence, though fleeting, has the potential to resonate far beyond our lifespan, shaping interpretations, influencing ecosystems, and leaving subtle fingerprints that testify to the existence of thoughtful, creative beings. And in that resonance lies meaning, not in permanence, not in monuments, but in the enduring capacity to influence, to innovate, and to leave a legacy detectable by those who come after. We are temporary, yet in the Earth's memory, temporary can endure. As we step back from the sweep of deep time and consider the possibility of civilizations before us or those that may rise after, we are reminded of the fragility and power of intelligence. Our moment is fleeting, yet the choices we make today ripple into the far future, leaving traces that may be read by generations yet to come. We are stewards not only of the present, but also of the story the Earth will remember. Every decision, every action, every effort to understand and protect our world matters. Whether through conservation, mindful innovation, or the careful sharing of knowledge, we have the power to shape what legacy our civilization leaves behind. So pause, reflect, and ask yourself, what mark do I want to leave on this planet? Not just for today, but for millions of years into the future. How can we act with awareness, curiosity, and care in a world that will continue long after we are gone? If this exploration of deep time, lost civilizations, and the enduring traces of life has sparked your curiosity, I invite you to keep asking questions, keep learning, and share these ideas with others. Imagine the possibilities, embrace the mysteries, and contribute to a legacy worth leaving. The past may be uncertain, the future unwritten, but the present is ours to shape. Subscribe, explore, and stay curious, because the story of life, intelligence, and civilization is far from finished.